And so we're just going to look at inference for proportions. All right, so these are the topics that AP says will be covered on the exam. Once we're through with this packet, we will be done with inference. I really don't know what else we can do more with inference. Also, I was thinking that since we just got done reviewing scatter plots and doing regression for exponential and power regression, that's going to be half of exploring data. The other half would be, histograms and box plots and dot plots, that kind of thing. So I'm put that in red, meaning that we're kind of half done. Sampling and experimentation, that's a big one. We were not good in that unit, and I don't know, I take some blame for it, but we need to cover this. I just have this feeling that that's going to be part of this test. Probability and simulations, I do feel a little better about that. That's your geometric, binomial, random variable, and then just rules for probability. We do need to cover that. I think the tough part of that will be the random variables, but I've got some good problems for that, so I think we'll be good to go. And we've got until AP exam starts, because once AP exams start, I don't want to burden you with a whole lot, because you've got to prepare, for each of your classes. And one thing that just drives me crazy is that I don't have preparation books for you. They're all sitting back at school. Every year I pass them out to kids who want them. They're good. They may not be as good as Princeton Review, but they're pretty good. But we're just going to have to chug along as best we can without them. Oh, and also, I'm thinking that those videos that the AP people are going to post are going to be very, very important. So I'm going to preview those, and I'm going to work those into what we're doing. Okay, so for proportions, really for all inference, when you think about it, all inference except for chi-square, you want to define the parameter. Remember, for chi-square, there may be too many of them. And besides, chi-square isn't on our exam, so who cares? All right, so mu of a difference equals P1 equals P2 equals, and you just say what it is in context. Definitely, when you get down to listing your results, name the procedure. Results for a 1 prop z test. All right, and it's not a 1 prop z test for means, it's a 1 prop z test. Okay, name it. That'll free you from having to write out the test statistic by formula, even though you'll get a formula chart. And it'll just allow you to use calculator speak. All right, when you start to list conditions, there'll be 3 that'll be common to everything. SRS is one, independent is another. So it might be independence within a sample. In other words, you're not picking the same person twice. It may be independence in between samples, like one person is not being shared between 2 groups, that kind of thing. And then your 10% rule, right? That's the population is at least 10 times the sample size. Those will be in everything that will be on your exam. Now, whatever's left over is going to verify normality, and it's going to be quite different for proportions and for means. So I'm not including those. Those would be like the 4th condition. So 1 prop z interval. Define the parameter. All right, that's p equals the true proportion of folks who are who pass this test. Assumptions, remember SRS and independent sample selection, your 10% rule, and we have to see if we can approximate normality of your sampling distribution. Remember, it's n times p hat, and n times 1 minus p hat are greater than or equal to 10. And we use the p hat because if we're estimating what p is, we don't know it ahead of time, okay? So those are your assumptions. Call it a 1 prop z interval and produce it on your calculator. So you're going to get some practice over that when you do that portfolio. Then interpret it. We are 95% confident that the true proportion of people who pass this particular test fall in the interval from blah, blah, blah to blah, blah, blah. And if the question refers to, like, do you see evidence that 75% pass this exam, then if both of your values are above 0.75, then you would say yes. That's good evidence for that. So if you need examples for this, everything is still posted on Canvas. All of that homework, all of the PowerPoints, all of the videos, they're there. All you've got to do is go to the front page, click on the link, and find problems to look at. All right, in case you need it, here is your formula for a 1 prop z interval. And remember, confidence intervals are always sample estimate plus or minus margin of error. Your margin of error breaks into your standard error times some kind of value related to your confidence level. Like 95% is 1.96 and 90% is 1.650, I think. But anyway, get out a z-table and look those up. In fact, if you don't have a z-table, there should be one up in Canvas somewhere, probably under your proportions area and under reprints. If not, just Google it and you can find z-tables all over the web. All right, a 1 prop z-test. Define the parameter. P equals the true proportion of people who voted in the last election. State HO and HA, right? HA is always going to be an inequality. HO is always equal to. They're basically the same assumptions that you had for 1 prop z intervals. But there's a little tiny bit of a difference. Right here we've got P naught and here we've got P naught, whereas before we had P hat. P naught is the value that you have up here for HO. HO P equals 0.5. Something like that. So P naught would be 0.5. All right, call it a 1 prop z test, perform it on the calculator, state your z value, your p value, your alpha value. You can put the p hat from your sample there if you want to, and provide a conclusion comparing p to alpha, or base it on strength of evidence. P is sufficiently small that the results are significant and we reject HO, that kind of thing. List any limitations or violations of assumptions. Don't just give up. Keep working the problem, but if you don't have a simple random sample, or if one of your products is below 10 for verifying normality of your sampling distribution, then list it there. Here's the formula for your test statistic, your z test statistic. And remember, it's what you observe minus what you believe to be true for HO over standard error. It's that way for every test statistic. So that's a 1 prop z test. Next we have the two proportions. All right, so a 2 prop z interval, define both parameters, P1 and P2. Your assumptions, SRS and independent samples, 10% rule for both, and then you're back to the same thing that you had for confidence intervals, because remember, when you do this, you don't really know what P1 and P2 are, so you're using the sample estimates. They both have to be, for both samples, all products have to be over 10 or greater to approximate normality of your sampling distribution. Remember, it is one sampling distribution. It's blended between the two random variables, for lack of a better way to put it. Call it a 2 prop z interval, pop it out on your calculator, interpret it. We are 95% confident that the true difference in proportions for blah, blah, blah. Look to report 0, because that's really kind of the only reason that we would do a 2 prop z interval, is to look to see if there is evidence of a difference, or if 0 is in your interval, that there isn't. Now they might say something like, do you see any way that, this could be like 30% or higher, and then you would look for 0.3. But normally you look for 0. All right, so here's the formula for your 2-prob z interval. Again, it's sample estimate plus or minus your value based on your confidence level times standard error. It's just more complicated. And remember, it is based on a difference. Now your confidence interval, it doesn't matter the order that you subtract, because if you look for 0 and it's not there, either both of your lower and upper values in your interval will be negative, or they'll both be positive, right? So order doesn't matter when you subtract. All right, a 2-prob z-test. Ooh, that's an artifact. All right, define the parameters. I'm not sure why they came up at once. Oh well, doesn't really matter. Define both P1 and P2. State HO and HA. Remember, HO is that P1 equals P2, and HA is similar, only with an inequality. Be careful with direction. If you get your direction backwards, remember you're going to get an abnormally high p-value, so watch for that. Assumptions, again, RS and independent samples. Populations are 10 times the sample size, and you're going to use the same checks for normality over sampling distribution that you did for the intervals, because there are no numbers up here for HO and HA, right? It's just P1 equals P2 without any kind of numbers that you could use for P naught. Call it a 2-prob z-test, do it on your calc, state your z-value, your p-value, and remember that weird blended p-hat number, record that too, your alpha value if you have one. Again, provide a conclusion comparing p to alpha or base it on strength of evidence. List any violations. And here's just for reference the formula for your test statistic. You're assuming that this P1 minus P2 is 0 because that's what HO is. So really it's just this, over this standard error. And see how you don't have a subscript for these two p-hats? In fact, these 4, those are going to be blended p-hats. All right, that's that weird formula, which I'm not going to trouble you with. We're not really responsible for it, and it's not on the formula chart.